In this video tutorial, you're going to learn how to create a scatterplot in Microsoft Excel. And a scatterplot is a type of data visualization that can be used to demonstrate the association or lack thereof between two different continuous variables. And so in this case, we're going to focus on two continuous variables that are job satisfaction and turnover intentions. And let's assume that these two variables, the data for them, were collected from an employee survey. So let's take a look at the data file here for this practice data set and orient ourselves to it. So notice that the first column here represents survey ID. This is just simply a unique identifier that represents the unique survey number. And so if we scroll all the way down, we'll notice that there are 148 unique entries, or rather 148 lines here. But if you take away that first line here, it means we have 147 unique survey responses here. Now, going over here to the next two columns, these are where our two continuous variables come into play. So the first one is job satisfaction here. And let's imagine that job satisfaction can range from 1 to 5, where 5 means very high levels of job satisfaction for the employee, and 1 means very low levels of job satisfaction, or other words, job dissatisfaction. So the way that these were computed behind the scenes is that there were 3 survey items for job satisfaction and 3 survey items for turnover intentions. So you could imagine that your employee going through the survey, and let's say you have the first item for job satisfaction out of the 3 states something like, in general, I'm satisfied with my job, and then the person can respond using a 5-point response format using either strongly disagree all the way up to strongly agree, where strongly disagree would correspond to a numeric 1 and strongly agree would correspond to a numeric 5. And let's imagine that the 3-point on that response format is neither disagree nor agree. Now, the same thing goes for turnover intentions here. And so the way you interpret these scores here is that higher levels or higher scores on job satisfaction mean higher levels of job satisfaction, whereas higher levels of turnover intention scores here mean that the person has higher levels of turnover intentions. So what that means is that they're more inclined, or they have greater likelihood or intention of quitting, let's say in the next 6 months. And so to describe these two variables here, we can use basic descriptive statistics to describe the mean and standard deviation for each. And if we want to try to understand quantitatively the association between the two variables, we can look at a correlation coefficient. So notice here that we've been looking at the raw data tab in our Excel workbook. Now, if we go over to the descriptive statistics work tab, what we'll see here is that we already have the means and standard deviations for job satisfaction and turnover intentions calculated for us. Remember, the mean is a measure of central tendency, and the standard deviation is a measure of dispersion. And so what we can see here is that on average, for this sample of employees, they tend to have slightly higher job satisfaction compared to that midpoint, which would be about 3, which would correspond to neither disagree nor agree in terms of the job satisfaction scale items that people are responding to. And then we see turnover intentions is right at about that midpoint here. And then we can see the degree of dispersion around those means in standard units here, which is 0.58 for job satisfaction and 0.61 for turnover intentions. Now, we can also calculate a correlation coefficient, which has already been done for you as well. And the correlation represents the quantitative association between two continuous variables, much like what we're going to try to depict visually using the scatter plot in a moment. And so here you'll see the correlation coefficient between job satisfaction and turnover intentions is negative 0.37. And if you recall, a correlation coefficient, specifically a Pearson product moment correlation, which is what this represents, can range from -1 to 1, where a perfect 1 would mean a perfect association between two variables, a perfect linear association. What that would mean is that in lockstep, for every 1 unit increase in job satisfaction, turnover intentions would increase by 1 unit. Of course, that would mean if the correlation was perfectly 1. Now, in this case, we see it is a negative value. And so if you could imagine on the other extreme, we have a -1. That would mean that for every 1 unit increase in job satisfaction, we would see a corresponding 1 unit decrease in turnover intentions. And this makes sense intuitively that this would be a negative association here, in that we would expect people who have higher job satisfaction to correspondingly have lower levels of turnover intentions. Now, This correlation coefficient, let's ignore the fact, let's not consider the p-value or statistical significance at this point, but instead let's look at the effect size here. This is negative 0.37. In the social sciences, or in other words, when we're dealing with human data, a correlation between two variables that is 0.37 or negative 0.37 would be considered to be about medium to large in magnitude or size. So this would be perhaps somewhat noteworthy here. Of course, before interpreting the size, we would also want to make sure that we look at the statistical significance, but that's beyond the scope of this class. And so for this moment, let's just consider this correlation coefficient here. Now remember, the correlation, specifically the Pearson product moment correlation that this represents, is supposed to represent a linear relationship between two variables. And what that means is that if the data were to represent a nonlinear relationship, such as an inverted U or something that's curvilinear in nature, or maybe something that even has a cubic form to it, functional form to it, such that you see two actual asymptotes in the relationship, well, then a Pearson product moment correlation would not be an appropriate metric here to look at the strength of the association and the direction of the association between two continuous variables. And so often we'll run a data visualization called the Scatterplot to understand visually the nature of this bivariate or two variable relationship before running a correlation. And so that's what we're going to do in the next step here. So let's create, by going down here to this little plus sign, create a new sheet. And another new sheet, or you could think of it as a new tab here. And I'm just going to arbitrarily call this data viz for data visualization, as we're going to create a data visualization, or specifically a scatter plot that represents the relationship between, or the association or lack thereof, between job satisfaction and turnover intentions. And so how are we going to do that? Well, let's go to the Insert tab here. And you'll notice that there's a number of chart options here that come standard in Microsoft Excel. Now, if you see the one that has the two axes here, and if you hover over it, you'll see scatter. Well, this is where you can find your scatter or bubble chart here. In other words, a scatter plot, which is what we'll refer to it as. So if you click on it, let's just do a simple scatter here to start out with. Okay, so if you click on this simple scatter plot here, you'll see that nothing appears. I'm just going to move it over here for the moment. And so what we need to do now is select the data for it. So let's click on this button here that appears up in the Design tab in Microsoft Excel. And now what we can do, we can see that our cursor is in the chart data range here. And so let's actually go over to the tab or the sheet that has our raw data. And if we simply highlight both columns here for both the job satisfaction and turnover intentions variables, and then you'll see that it's represented here. So it's referencing the raw data sheet, which it puts in single quotes, and then it uses an exclamation point to note that the first vector here is B to 1. So this is cell 1 in the B column of the raw data sheet here, and all the way to the C column and the row at the very bottom, which would be 148 here. So let's click OK. Okay, so now we have a scatter plot. Now, Excel doesn't do a great job in terms of giving us meaningful access labels. In fact, it just gives us turnover intentions as the main title here, which let's go ahead and delete that. So you can click on this, do a right click and delete if you'd like. Okay, and so you'll see it's adjusted here. Now, the way that Excel defaults, if you look back here, the first column that is listed is going to be on the x-axis, and the second one will be on the y-axis. So you have to remember that when you go in here to this plus sign, and let's add in the axis titles here. Okay. Now, again, you unfortunately have to do this manually, and so I'm going to title this Job Satisfaction on the x-axis, and on the y-axis, Turnover Intentions. Okay. And now you'll see here, this is the association, the distribution between the two variables here. Excel does an okay job of representing this. One of the issues, though, is that it doesn't really give a density plot here showing the strength of the relationships. They do have a bubble plot option that does an okay job, but it still leaves something to be desired in terms of showing the density. But nonetheless, we can begin to see that negative relationship represented here. And you can see it's probably more or less linear. You can imagine the line here. In fact, You could even go over here to the add chart elements here, and you can add in a trend line if you want to visualize that. So here you go. You can see that negative relationship here. Again, I would recommend not necessarily doing this, but sometimes it helps to understand what the potential trend line would be. This is essentially a regression equation that is being modeled here for you, so you could understand kind of the nature of the relationship here. But what you're looking for here is that you don't see any indications of nonlinear relationship. For instance, if you were to see the plots in an inverted U like this, it would indicate that using a correlation coefficient would not be appropriate. But here we can visually kind of see that as scores on job satisfaction get higher, turnover intentions tends to get lower. Okay, and so you can see that negative relationship. Now notice that all of the dots here do not lie on this line of best fit. And what that means is that this is not a perfect negative relationship here. And this is why the magnitude of the relationship is negative 0.37 if we look back here at the correlation coefficient, and not negative 1. Now, if it were 0, and remember with the correlation coefficient, 0 means there is no association or relationship between the two variables. Well, it would probably look something that's maybe just a mass of bubble or mass of dots here without any kind of structure, linear trend, or anything like that. Okay, so this is how you can visualize your data using when you have two continuous variables and you want to look at the strength and the direction of the association between two variables. You can use a scatter plot here. And so there are different ways that you can format it here in Excel, change the colors and so forth, and you can play around with those up here. As you hover over, you can get some previews of what that might look like. Here you can see you do get a little bit of that density function here to see where which dots that you have overlapping scores at. You can see that here, but again, it's not really that great when it comes to depicting the strength of the relationships here. So again, Excel is pretty good at this, but it's not meant to be essentially a really strong presentation-worthy data visualization tool. There's other platforms like Tableau, R, and Python that do a much better job when it comes to creating data visualizations. Nonetheless, this tutorial is meant to give you a preview of how that might work. So this wraps up this tutorial on how to create a scatter plot using Microsoft Excel. Thank you.